Assalamualaikum and hi everyone. How are you today? In this lesson, you will learn the last properties of Laplace transform, which is multiplying by the n function. Okay, you will apply this property when you see t power of n multiply with other function of ft. Okay, for example, we want to find Laplace of t multiply with cos. Okay, Laplace of t multiply with exponent, or Laplace of t power of 2 multiply with sine 4t. Okay. Alright. So look at table of Laplace transform. Okay, this property is given by formula 11. We will see that Laplace of t power of n multiply with ft. This is the solution. This is the answer. Okay, let's look at how to solve Laplace transform using this property. Okay, from the table, you can see that Laplace of t power of n multiply with ft equal to this formula. First step is to find n and ft from the function. Okay, and then from ft, find fs. Okay. Okay, after that, substitute n and also fs in this formula. So substitute and solve. Okay, how to solve the formula? So look at this one. So you must know how to differentiate fs. Let's do some revision about power rule. Okay, let's say you have a question A, y equal to 3x minus 1 power of 2. So we want to find y prime. So we have y prime equal to, okay, first step, these two bring forward. And then you will have 3x minus 1. And then from 2, you minus 1. Because you already bring 2 in front. You will get 1. 2 minus 1 is 1. And then after that, differentiate inside the bracket. You will get 3. So simplify. You will get 6 3x minus 1. Okay, remember, there are 3 steps to do power rule. First step is to bring forward 2 and then minus 1. After that, differentiate inside of the bracket. Okay, let's look at question B. If you see this kind of question, okay, this one refer to differentiate. Okay, d power of 1, ds power of 1. So you differentiate this function one time. Okay, if you see this function of s and on top of this function we have constant. Okay, on top we have constant. Okay, then proceed with power rule. Okay, first bring this function on top. So we'll have 3s squared plus 9 minus 1. So to differentiate this function, just follow power rule. So we have 3 and bring negative 1 in front to get negative 1. Then just copy back the bracket. Then we have negative 1 minus 1. Then differentiate inside of the bracket, we will get 2s. After that, simplify. You will get negative 6s s squared plus 9 negative 2. Okay, for question C, you must apply quotient rule. Okay, you will apply quotient rule if on top of the function we have function of s. We have s. So remember, if there is constant on top, you can proceed with a power rule. If you have s on top, function of s on top, you must do quotient rule. Okay, to do quotient rule, so we have the formula. Let's say y equal to u over v. So y prime, okay, differentiate of y, you will get vu prime minus uv prime divided by v square. So for this function, s is u, s square minus 1 is v. Okay, so to differentiate this fs, vu prime, so v is s square minus 1 u prime. Differentiate s, you will get 1 minus u is v prime is, and then divide by v square, s square minus 1 square, and then simplify. We will get s square minus 1 minus 2 minus 1 square equal to negative 1 minus s square, okay, s square minus 1 square. Okay, let's look at example 1. Okay, find Laplace transform using properties of Laplace transform. Okay, for question A, we have ft equal to exponent 2t t. Okay, so for all these questions, you must apply properties of Laplace transform. In this lesson, we will apply multiplying by tn property. Okay, look at question A. ft equal to exponent 2t multiply with t. So we want to find Laplace of exponent 2t t. If you refer table, you can see that t power of n multiply with ft. So rearrange the function, so t exponent 2t, and then after that determine n and ft. So n equal to 1 because t power of 1. Then ft equal to exponent 2t. And then from this ft, find fs. So look at table for exponent 2t. You will get fs equal to 1 over s minus 2. From this one, a equal to 2. After that, substitute n and fs in this formula. So we have Laplace of t exponent 2t equal to negative 1 power of n. N is 1. d 1 over ds1. And then put fs. So we have 1 over s minus 2. And simplify negative, we will get negative. So negative d over ds 1 over s minus 2. Then differentiate this fs. So look at on top of this function, we have constant. So remember, apply power rule. We have negative 1 here. First, simplify the function. We get s minus 2 minus 1. After that, differentiate this function. The first, put the negative 1 in front. We get negative 1 s minus 2. Negative 1 minus 1, you will get negative 2. Then differentiate inside of the bracket, you will get 1. And simplify, you will get negative, negative, positive, s minus 2, negative 2. Or 1 over s minus 2 square. Okay, for question B, we want to find Laplace of t square sine 2t using by tn property. So first determine n and ft. So from question n equal to 2, okay, 2, ft equal to sine 2t. This one. And then find from ft, find fs. Look at the table. You will see, so a equal to 2. We have 2 over a square plus 4. Okay. And then step number 3, substitute all into formula. So we have 2t equal to -1 power of n. N is 2 d2 over ds2 and fs. Then try to simplify. -1 square is positive. Okay, for this example, you have to differentiate 2 times. Okay, look at the function. We have constant on top. So you must apply power rule. So first simplify the question. We have 2 s square plus 4 -1. Then differentiate the first time. So we have 2 -1 s square plus 4 -2 2s. Okay, then simplify. Look at -4s over s square plus 2 power of. Okay, then differentiate again. You will realize that on top you have function of s. So you must apply quotient rule. So u equal to -4s, v equal to s square plus 4 square. Okay, quotient rule, y prime equal to v u prime minus u v prime divided by v square. Okay, so you will get v so s square plus 4 square, differentiate u will get -4 minus u is -4s, differentiate v. Okay, apply power rule. 2 s square plus 4 1 2s. Divide by v square. So s square plus 4 power of 4. And then simplify. And we have common factor here, s square plus 4. So factor out and leave with s square plus 4 -4. Then multiply all. We will get plus 16s square divided by s square plus 4 power of 4. Okay, then you can cancel out. To that expand, get -4s square minus 16 plus 16 s square divided by s square plus 4 power of 3. Then simplify, we get 12s squared minus 16 over s squared plus 4 power of 3. Okay, for question C, we want to find Laplace of negative 2t cos t plus t squared exponent negative 3t. Okay, we have plus here, so you can apply linear property and separate the function. And then you have constant here, factor out constant. And then we want to apply multiplying by Tn property. Okay, first we separate, solve the first function. Okay, Laplace of t cos t. So first step we find n equal to 1, ft equal to cos t, so a equal to 1, and then find fs equal to s over s square plus 1 square. 1 square is 1. Okay, and then substitute into formula. So we have negative 1 power of n. N is 1. d1 ds1 s over s square plus 1. And simplify. Okay, look at this function of s. We have s on top. Then you must apply quotient rule. So we have u equal to s, v equal to s square plus 1 equal to negative 1, v u prime. V is s square plus 1, u prime is 1 minus u, v prime is, u prime is 1, v prime is 2s. 2s divide by v square, so s square plus 1 square. So simplify, you will get minus s square. Apply negative 1, you will get negative 1 plus s square. Okay, so for function 1, this is the answer. Then solve for function 2. Laplace of t square exponent negative 3t. Okay, look at this function. Actually, you can solve this function by using 3 methods. First, you can directly find the answer in the table. We have t and multiply with exponent at. Or you can use first shift, because we have exponent negative 3t multiply with t square. Exponent multiply with function of t. So you can use first shift. And you can apply multiplying by Tn property, because we have Tn multiply with function of t. So for this question, you can use 3 property. However, in this lesson, you will solve using multiplying by Tn. Okay, first determine n and ft. So a equal to negative 3. So fs, look at table. You look at fs equal to 1 s plus 3. and then substitute in the formula. Negative 1 power of 2 d2 over ds2 function of s plus 3. Okay, look at function of fs. We have 1 constant on top. So apply power rule. So g square over ds square s plus 3 negative 1. We will get and differentiate the first time. Get negative 1 s plus 3 negative 2 1. Then differentiate again. Negative 1 negative 2 s plus 3 negative 3 1. Then simplify, we get 2 over s plus 3. Okay, this is the answer for function 2. The final answer for question C is, so we have negative 2 Laplace of okay, this is the final